そうしましたら次のスピーカーで、次のスピーカーはですね、またオープンファウンデーションモデルなんですけども、マリタイム分野で、それをファウンデーションモデルをトライアルしていただいている古野電機様の技術研究所の田中様より発表いただきます。
すいません。
このマイクでよろしいですかね。
スライド見えないですかね。
あれ、スライドが見えないです。
見えるかな、見えないかな。
スライドは。スライドがそこに見えないんで。あ、見えた。はいはい、見えました。はい。
ありがとうございます。
マイクお願いします。
ありがとうございます。
これクリックできます。
はい。Thank you for the introduction. Good morning, everyone. My name is Mika Tanaka, and I work at Phone. Actually, I'm not good at English, but I'll try to speak in English. I would like to talk to you about the possibility of AI agent in the maritime industry and the foundation models that support them. I hope you will see how these technologies can help ship, ports, and the people who work at sea. Let me show you today's agenda. First, I will very short company introduction. Then I will explain the challenges the maritime industry. After that, I will share our vision for the maritime industry. Next, I will talk about our first step, the LLM for the maritime industry. Finally, I will give the conclusion, the next steps. Let's get started. Now, let me introduce our company. We are not very well known outside, so I will tell you a little about us. We started by inventing the fish finder. Since then, we have made many products for ships like sonar, AIS, and radar. Our core technologies are sensing or signal processing and integrated systems. We also make industrial equipment. Our business began at sea and grew with the sea. Today, we aim to be an AI leader in the maritime industry. Now, let's look at the 4 main challenges in the maritime industry. First, complex regulations. Ships follow many conventions and laws, and update bring a lot of paperwork and cost. Second, workforce shortage. The crew supply is shrinking worldwide, and it's hard to train new crews quickly with old methods. Third, data overload and digitalization. Modern ships produce over 20 gigabyte data every day in different formats. Manual analysis is hard, so we need real-time predictive tools. Finally, strict safety demands. Maritime rules are very strict. New risks like cyber attack and extreme weather make it even harder. We need first reliable support. AI can help solve these challenges. Now, I will share our vision for the maritime industry. We want to place AI agent all around the ship. A navigation AI agent to help with complex maneuvers. Training AI agent to keep and share crew expertise. Compliance AI agent to read documents and make reports automatically. A safety AI agent to watch for risks in real time. These agents run autonomously on board. If needed, it sends data to the cloud and perform the required processing. With this vision, we can give every ship a safer and more efficient voyage. Let's walk through our system concept. At the very top, is the agent workflow. Think of it as the conductor of an orchestra. It calls the program store, where we keep our numeric modules. It also puts up the knowledge store, which holds each ship's SOPs, voyage logs, and frequent updated information. Once it has the right code and data, it hands everything off our domain-specific LLMs. Those LLMs act as the agent brain packed with maritime expertise and enforcing strict safety rules. We build our models in these layers. First, 3 layers. First, a generic foundation model gives us basic language scale. Next, we fine-tune it on maritime documents to add ship and sea knowledge. Finally, we inject full node's internal manuals and data so it really knows our equipment inside and out. The architecture is fully modular. When a new regulation appears or different vessel type needs support, we simply retain or swap one layer. There's no need to rebuild the entire system. And that's how we AI agents stay both flexible and deeply knowledgeable, ready to deliver safe, compliant real-time guidance anywhere at the sea. Now, let me share our progress with Lamarine. In collaboration with Automatic, we've released Lamarine version 1.0, the maritime industry first open source large language model. It incorporates public maritime terms, regulations, and operational knowledge, and was trained using textbook, research papers, and maritime-related Wikipedia contents. Next, we compare Lamarine agent general model on our evaluation dataset. Across the board, Lamarine delivered stronger, practically more expert-level communication and clear use of examples. Now, I'd like to introduce a simple navigation support app powered by Lamarine. On screen, you see basic encounter scenarios. You enter the relative bearing and speed of your own ship and an approaching vessel. The agent instantly analyzes the situation and then suggests the optimal action to avoid a collision. This demonstration illustrates Lamarine's potential to turn sensor data into clear, actionable guidance in seconds. You will see that we've published all the project details and an archive preprint. Feel free to dive into the paper for the full methodology, experiments, and results. Check it out. That's wrap up our findings. Lamarine proves that a maritime-focused LLM can boost safety, efficiency, and compliance at sea. Next, we plan to use more realistic data to manage knowledge and learning for each vessel. We also want to build multimodal models for enhanced capability. Another key point is developing robust agents that can handle high-quality demand in the real world. Of course, our ultimate goal is a safe, efficient, and scalable AI suite for all maritime stakeholders. Thank you for listening.
Thank you, Tanaka. Okay, so as you know, we are running out of time, so I have a couple of announcements. One bad news, we skip coffee break. But the good news is we still provide a very nice lunch, so we keep a lunchtime available. So please stay until lunchtime. And then also I switch over my MC to my colleague, Tak Otsu. So Tak Otsu will take over MC.